In the last class, we have solved some problems by using Laplace inverse, and today we are going to learn two new techniques, that is completing the square, and the second one is partial fractions. Now let's see. Already we know this property. If Laplace of f of t is equal to f bar of s, then Laplace of e power at f of t is f bar of s minus a. We know this, right? Same property we are going to use for inverse. I am saying L inverse of f bar of s minus a is equal to e power at into L inverse of f bar of s. You can note this down. We will be using this in the problems. And one more thing, if you have a question of this format, phi of s by ps square plus qs plus r, okay, what we will do is the denominator we will write it in terms of square, s minus a the whole square. It could be plus or minus b square, because we have formula for s square plus a square and s square minus a square in the denominator. But here it is s minus a, right? In this case, we will shift it back to s by using this property. Okay, so the idea is first I have to write the numerator and denominator in terms of this format. S minus a should be there in the numerator, denominator also s minus a the whole square plus or minus b square. Then we will shift it back by using this property, and then applying inverse for a small function will be easier. Now let's see few problems. Find Laplace inverse of s plus 5 divided by s square minus 6s plus 13. First of all, I have to split this denominator. I have to complete the square. How is it possible? See this denominator, s square minus 6s plus 13. I can split this 13 as 9 plus 4. Okay, so then it's easy for me. S square minus 6s plus 9 is s minus 3 the whole square, and plus 4 is 2 square. Now it's like s square plus a square. Right, now the denominator is in the formula format, and I want numerator also in terms of s minus 3. Then in that case I can shift back from s minus 3 to s, and then I can apply my Laplace inverse transform. Correct? So what is there in the numerator? S plus 5. How to split that? S plus 5, what I will do? Minus 3 plus 3. So I will group this minus 3 along with s. S minus 3 plus 3 plus 5 will become 8. Now see the problem. It's completely in terms of s minus 3. The numerator as well as the denominator. Wherever s minus 3 is there, I'm going to replace it by s. So in the place of s minus 3 I have written s. The place of 8 I'm writing it as it is. Denominator s minus 3 the whole square. So I have written s square. 4 anyhow I have written 2 square already. Now I have shifted s minus 3 to s, right? So what I should do? I should multiply with e power at. If it's s minus a, e power at. So here s minus 3. So e power 3t. So I have used the property. Okay. Now it's easy. S by s square plus 2 square is first term, plus 8 into L inverse of 1 by s square plus 2 square is second term. So first term is very easy. Cos 2t is the formula. Second term, I want 2 in the numerator. Remember what is the formula? A by s square plus a square. 2 is not there. So from this 8, I will take 1 2 and multiply this inside. So this will become 4 into sin 2t. Please be careful. Sometimes we will write 8 sin 2t here. So write down all the formulas that we have used. What are the formulas that we have used? The property, that is L inverse of f bar of s minus a is equal to e power at into L inverse of f bar of s. That is the first formula. Second formula is Laplace of cos 2t is s by s square plus 2 square. Third formula is Laplace of sin 2t is equal to 2 by s square plus 2 square. Okay. Now let's see one more problem. And this problem is find Laplace inverse of s square by s plus 1 the whole cube. Okay. So the denominator already in terms of s plus 1. I want the numerator in terms of s plus 1. So the denominator is fixed already. I have to change only the numerator. Now coming to the numerator. What is the numerator here? S square. S square I can write it as s plus 1 the whole square minus 2s minus 1. Right? Because s square plus 1 plus 2s will come. minus 1 minus 2s, it will get cancelled, so I will get only s square. So this is the equivalent form of it. From this is s plus 1. Here, wherever s is there, I should have s plus 1, right? I should write it in that format, then only I can convert it back. So you cannot leave the numerator as, okay, we got s plus 1 so that we can move on. No. Wherever s plus 1 is there, you are going to change s. So what you will do with this s? So this s also I have to write it in terms of s plus 1. Yeah, now you can see I have written it in a little hurry. So this is what we got in the book. So this minus 2s, I am keeping it as it is. Again I am adding 1 and subtracting 1. Okay. So this minus 1 is there as it is. Minus 1 plus 1. I am adding and subtracting one term. Okay. So these two will become minus 2. Now I can take minus 2 common from this term and these two terms. So minus 2 if I take common, yes, and this negative has gone. So I will get plus 1. Remaining plus 1 I am having as it is. Then I will be using this format. What is that? L inverse of f bar of s minus a is e power at into L inverse of f bar of s. Here in the place of s minus a, I have s plus 1. Remember, s plus 1 you can write it as s minus minus 1. So in the place of a I have minus 1. Correct? So when you are using this formula, please be careful with the sign. So I have rewritten the same problem like this. Denominator I am keeping that as it is. Numerator I am writing in terms of. So there shouldn't be any s term left over. Wherever s is there, only I should have s plus 1. Then only I can shift it back completely. So now we are going to shift back to s. Wherever s plus 1 is there, I am going to write s. So L inverse of, I will write s square minus 2s plus 1 by s cube. Very beautiful. And to compensate that, what I have to do? I have to multiply with e power at. Right? In the place of a, just now I wrote minus 1. So e power minus t. And one more short trick I told you. If it's plus symbol here, outside minus symbol will be there. Very simple. E power. So in the previous problem, s minus 3. So I have written e power 3t. Correct? Here s plus 1 is there. So e power minus t. That's it. So don't forget to multiply with e power minus t when you are changing s plus 1 to s. You are shifting it back. Okay, and then e power minus t is there outside, and please don't bring it to this, because the formula itself is e power at into L inverse of leftover terms. So this term should be there outside. So L inverse of s square by s cube, 1s will be there in the denominator. So L inverse of 1 by s, first term. Again here 1s will get cancelled. Minus 2 into L inverse of 1 by s square is the second term. And then plus L inverse of 1 by s cube is the third term. What is the corresponding formula? Laplace of t power n. Remember? So this L inverse of 1 by s, Laplace of 1 is 1 by s. So L inverse of 1 by s is 1. Minus 2 into, this is t power 1. That is by 1 factorial by s power 1 plus 1. Same thing. So minus 2 into t plus, and this term. What is Laplace transform of t power 2? It's 2 factorial by s cube, that is 2 by s cube, right? 2 is missing. So I'll multiply with 2 in the numerator as well as denominator. So 1, 2 will go inside the formula. The other 2 will be there in the denominator. So that is why t square by 2 has come. That's it. So you're going to adjust the numerator and denominator in the formula format by completing the square. This is the technique I'm talking about. You can try few problems on your own, but before that, try to study the formulas properly. Let me check your idea over here. Find Laplace inverse of s plus 2 by s plus 1 the whole power 4 into e power minus s. E power minus s is there in the numerator. First of all, what is the formula or property that is associated with e power minus as in the question itself? Remember this? Laplace inverse of e power minus as into f bar of s is f of t minus a into u of t minus a. The unit step function. By using this, we have solved problems in the previous video. So finally, we will use this property. Okay. So before solving this, first of all, we'll try to simplify the terms or find the inverse for the terms which is there inside along with e power minus s. This finally we will use it, the unit step function formula. So you don't worry about this whenever you have e power something in the question. So you take the terms that is along with that, s plus 2 by s plus 1 the whole power 4. So I have to simplify this and find the Laplace inverse. Finally we can address that e power as thing. Okay. So now denominator is already s plus 1 the whole power 4. So I want to bring the numerator also in terms of s plus 1. This is very simple. So this plus 2 I can split it as plus 1 plus 1. So s plus 1 plus 1. Wherever s plus 1 is there, I am going to shift to s. So Laplace inverse of s plus 1 by s power 4. After shifting, don't forget to multiply with e power that corresponding term. And the simple technique I told, if you have a plus sign here, you are going to write e power minus t. If you have s plus 2, you will write e power minus 2t. If you have s plus 3, you will write e power minus 3t. And so we multiplied with e power minus t here, plus 1t. Here 1 is there, so a is minus 1 here. So we have written e power minus t. And this is outside the inverse, so don't worry about this term. Okay, we are going to find the inverse for the terms which is there inside the bracket. We are going to split it. S by s power 4, so 1 by s cube, Laplace inverse of that. And already we got Laplace inverse of 1 by s cube in the previous problem itself. That is t square by 2. And Laplace inverse of 1 by s power 4. So by using that formula, we got this is t cube by 6. Because Laplace inverse of 1 by s power n plus 1 is t power n by n factorial. Whichever term is missing, that will be there in the denominator. Okay. Now we are done with this and we are going to use this formula. We know Laplace inverse of the terms f bar of s. Then Laplace inverse of e power minus s into f bar of s is f of t minus a into u of t minus a. Okay. So here a value is 1. And please don't get confused with the formula. The formula is L inverse of e power minus as into f bar of s is equal to f of t minus a u of t minus a. So e power minus as is there in the formula. Okay. So a is 1 here. So that is why t minus 1 u of t minus 1. Okay. So we are finally replacing the values, that is changing t to t minus 1. So we have e power minus of t minus 1 the whole square by 2 plus t minus 1 the whole cube by 6 into u of t minus 1. So whenever you see e power something in the question, leave that e power term, find the inverse for the leftover terms, and finally use this unit step function formula. Okay. And if you see this problem, only s is there. So I have to write denominator and numerator in terms of complete square. So the denominator I have written s plus 2 the whole square plus 25. First you always fix the denominator. Okay. So s plus 2 the whole square plus 5 square. Denominator is fixed. Now numerator I want in terms of s plus 2. So you have to do the simplifications accordingly. You can try this problem on your own. Just take a look at it and answer is also given. Just try this. These are all simple problems. So whenever you have e power something over there, then you will be using unit step function also. And you may get fractions also when you are completing the square. For example, see this problem, s square plus 3s plus 1. So to complete the square, this is the denominator. I am talking about the denominator. Numerator is 2s plus 1. Leave that. So first we will fix the denominator. S square plus 3s plus 1. I am writing it as s plus 3 by 2 the whole square minus 9 by 4 plus 1. Then only it will come in this format. And see here, s plus 3 by 2 the whole square minus this term. I can write it as, I will get 5 by 4, right? Minus 9 by 4 plus 1, I will get minus 5 by 4. 5 by 4, how I will write it as a complete square? We know for 4 it is 2. So 5 in the numerator, I will write root 5 by 2 the whole square. That's it. So once you fix the denominator, you want the numerator also. 2s plus 1 also, I will write it in terms of s plus 3 by 2. So your aim is to complete the square and you will write it as s square plus or minus a square or b square, whatever it is. Okay, here plus or minus sign can come, but here it should be something the whole square, and in this format only the numerator also I want. That is the idea. So these are the problems based on completing the square. Now let's see inverse Laplace transform by the method of partial fractions. For example, if the given problem is like this, find Laplace inverse of this term phi of s by psi of s. If degree of phi of s, that is the numerator, is less than degree of psi of s, then we can resolve it by using partial fractions. Now see this problem, find Laplace inverse of 1 by s into s plus 1 into s plus 2 into s plus 3. So now I know what is Laplace inverse of 1 by s. I know what is Laplace inverse of 1 by s minus a, that is in general, correct? So I can apply the formula if it's in addition. So what we are going to do, we are going to resolve it by using partial fraction, that is a by first term plus b by second term plus c by third term plus d by fourth term. Simple one. Okay, and now we have to take LCM on both sides. If we take LCM, the denominator on both sides will get cancelled, and what you will get, only the numerator, 1 into a into, how many terms will be there? S plus 1, s plus 2, s plus 3. So in case if you are getting confused, now out of these 4 terms, check the denominator of a, yes. Hide this term s and multiply a by the leftover terms. Similarly, b denominator is s plus 1. So in this 4 term, hide only s plus 1, and what are the leftover terms? Yes, s plus 2, s plus 3. So you will multiply b with that leftover term. Similarly, plus c by s plus 2 is there, so you are leaving s plus 2, you are going to multiply with s plus 1, s plus 3 with c, and finally d s plus 3 is there, so I will multiply d with s plus 1, s plus 2. So it's a simple technique of taking LCM, that's it. Now I will substitute suitable value to find the value of a, b, c and d. Okay, for example, if you see a, if I substitute s as say minus 1, then a will vanish and then b will be there. Okay, here c will vanish and d also will vanish. So if I substitute s as minus 1, I will get only b. So 1 is equal to b into minus 1 plus 2 minus 1 plus 3. Okay, so and then outside one more minus 1 is there, so we will get 1 is equal to b into minus 2. So we got b. Similarly, if you substitute s as 0, then what will happen? If I substitute s as 0, b will become 0, c will become 0, d also will become 0. I will get only a. 1 is equal to a into 1 into 2 into 3. So 1 is equal to a into 6, therefore a is 1 by 6. Similarly, if you substitute s as minus 2, because of this term a will become 0, because of this term b will become 0, and there is no s plus 2 here. So I will get the value of c, and d also will become 0. So 1 is equal to, we will get this, c into 2. So we got c. Similarly, if you substitute s as minus 3, a will become 0, b will become 0 because of these terms, s plus 3. C will become 0, so you will get d value. So now you got all the values a, b, c, d. You are just going to substitute in this equation. Okay, so Laplace inverse of this question becomes Laplace inverse of this one. So take out the constants. So 1 by 6 into Laplace inverse of 1 by s. Then minus 1 by 2 into Laplace inverse of 1 by s plus 1 plus 1 by 2 into Laplace inverse of 1 by s plus 2 minus 1 by 6 into Laplace inverse of 1 by s plus 3. Okay, even if you make a mistake, your mistakes will be along with the corresponding constants. But these formulas are same. You know your answer in the beginning itself. What is Laplace inverse of 1 by s? That is Laplace transform of 1 is 1 by s, right? So Laplace inverse of 1 by s is 1. 1 by 6 into 1, 1. Minus 1 by 2 into, here 1 by s minus a. So s minus minus 1. S plus 1 I can write it as s minus minus 1. So in the place of a I have minus 1. So e power at is the formula, e power minus t. Here in the place of a I have minus 2, e power minus 2t. Here in the place of a, because your formula is a Laplace inverse of 1 by s minus a. So s minus 3 I can write. So a is minus 3, so e power minus 3t. So this is the solution. Now resolving it into partial fractions, already you know, here it's a simple denominator. Okay, so even if you see this problem, simple denominator, so a by s plus b by s minus 1 plus c by s plus 2. We have numerator here, that is not going to affect us. So we are going to take LCM, and on the left hand side we'll be having these values. So you will be substituting suitable values for a, b and c. What are those values? When a will become 0, when b will become 0, when c will become 0. If I substitute s as 1, I'll get a will become 0. If I substitute s as minus 2, b and as well as a will become 0, I'll get c. So if I put s as 0, then b and c will become 0, I'll get a. Same as what we have done in the previous problem. You can check the solution, because this is a very simple problem similar to the previous one. You can try this problem on your own. See this problem, they have asked this in model question paper also. Laplace inverse of 3s plus 2 by s square minus s minus 2. I can split this as s minus 2 into s plus 1. So it's easy partial fractions. There are certain problems you can solve it by completing the square also. So whichever is easier, you go for it. Some problems we can solve it by partial fractions, or you can solve it by completing the square. So in that case, you can decide whichever is easier for you, you can go for it. Now see this problem, s square plus 1, s square plus 4 is there in the denominator. We will be wondering how we can resolve it into partial fractions. Numerator is also s square is there. So we can substitute s square as some t. Now your problem will change, t by t plus 1, t plus 4. Now you can resolve it into partial fractions, a by t plus 1 plus b by t plus 4. Again taking LCM, okay. And if I substitute t as minus 4, a will vanish, I will get b. If I substitute t as minus 1, b will vanish, I will get a. Same thing they have written, okay. I'm just leaving the taking LCM and the simplification part. I'm just giving you an idea. So sometimes if everything is in terms of s square, you can replace s square by t and make it as a simple problem. Once you resolve it into partial fractions, then you can write it back in terms of this original problem. So after I'm resolving it into partial fraction, minus 1 by 3 into 1 by t plus 1. So now I'm going to replace t by s square. So minus 1 by 3 into L inverse of 1 by s square plus 1 plus 4 by 3 into L inverse of 1 by t plus 4, I will write it as s square plus 4. Now we have the formula for it. What is the formula? 1 by s square plus 1. This is the formula for sin t, correct? And here it is 2 sin 2t, because a by s square plus a square. We want 2 by s square plus 2 square. So we will multiply by 2 and divide by 2 to this term, so that 1, 2 we can take it for the formula, and the division 2 will be there, right? That 2 and this 4 will get cancelled. Or you can do this, you can take 1, 2 and split it here for the formula, and you can keep the other one as it is. Because of the negative sign, I have written this first term as a second term. That's it. One more thing, how you are resolving it into partial fractions, I hope already you know it, but still just for a safer side, I am explaining this. If you see this question, find Laplace inverse of 4s plus 5 divided by s plus 1 the whole square into s plus 2. So here the whole square is there, right? So a by s plus 1, so plus b by s plus 1 the whole square. This is how we split it. Plus c by s plus 2. So now you will be taking LCM, or you can use the short trick. Write down the numerator as it is. Denominator s plus 1 is there, right? So in this s plus 1 whole square, 1 s plus 1 is there in the denominator. So leftover is 1 more s plus 1 and s plus 2, multiply a with that. Here b denominator s plus 1 the whole square is there. Hide this term. And what else we have? S plus 2. Multiply b with s plus 2. Again c denominator s plus 2 is there. Okay. So hide s plus 2. What is the leftover term? S plus 1 the whole square. That you have written along with c. Now what are the values you will substitute? If I substitute s as minus 1, a will become 0 and I will get b. C also will become 0. So 4 into minus 1 plus 5. So minus 4 plus 5, so I have got 1. Same way this is 0, so I have to calculate only here. B into minus 1 plus 2. So 2 minus 1 is 1. 1 is equal to 1 into b, therefore b is equal to 1. Similarly, if you substitute s as minus 2, you will get c. And sometimes you can compare the coefficients also to get this desired answer. Some people will substitute s as 0 and they will get an equation, and then they will substitute the known values and they will find the unknown value. But here comparing the coefficients will give you the faster answer. For example, see coefficient of s square. Here is there any s square term over here? No. No s square, right? Only s term and constant term, so I have written 0. Here what is, just check only s square term. S into s square, a s square, write down only a. Don't write s square, we are comparing only the coefficients. Here b, yes, there is no s square term, so b will not come. Here s square plus 1, if you expand, c s square will come, so I will write 0 is equal to a plus c. We know what is c, therefore we got a. So we can use the idea of comparing the coefficients to get the desired result. So finally we are going to substitute in this equation. So in the place of a I have 3 into L inverse of 1 by s plus 1. What is this formula? E power minus t. Plus in the place of b I have 1, s plus 1 the whole square, correct? So s plus 1 the whole square, remember we will shift it back to s and multiply with e power at. Here I told you if plus sign is there, write minus, because we are using the property Laplace inverse of f bar of s minus a is equal to e power at into Laplace inverse of f bar of s. This property we are using, that is what I told. Here s minus a is there means then you write e power plus at. If s plus a is there, you will write e power minus at, just opposite sign. Here in your problem you have s plus 1. So we are writing e power minus 1t into L inverse of wherever s plus 1 is there, replace it s. Laplace inverse of 1 by s square. Minus 3 into, now this is a direct formula, Laplace inverse of 1 by s minus a is e power at. So s minus minus 2. A is minus 2, so I have written e power minus 2t. If you are not thorough with the formula, you may get confused. But at the same time, if you are thorough with the formula, these are all nothing for you. When you are writing the sign, please be careful whether it's plus or minus. For that, every day you have to go through the formula at least once, then it will be there in your memory. So now Laplace inverse of 1 by s square, this is t power 1, right? Laplace inverse of 1 by s square is t power 1, so we have written this. So what are the formulas we have used? Laplace inverse of 1 by s minus a we have used. Laplace inverse of f bar of s minus a is equal to e power at into L inverse of f bar of s we have used, and Laplace inverse of 1 by s square is t power 1. So whatever the formulas that you have used, please mention here. In this book it's not mentioned, but there is a step mark we have, so you have to write down the formulas that you have used. And finally, see this problem, this is just for your idea. If you see the denominator, this is s minus 1, this is a quadratic equation. Remember how we will split a by s minus 1 plus bs plus c by second term. So this you might have studied already. So you may get any type of partial fractions, and the other things are same, taking LCM and substituting suitable value to get the desired result and all those things. You can see the solution as well as the answer. You can try this on your own. Thank you.